All the pieces and then love to that. Oh, I had to take this out. Oh, well, dude, it's like on the exposed.
Okay, folks, I think we'll go ahead and get started. It's wonderful to welcome all of you, both to this course, and for me, the first time I can welcome you all to APU. For my classes, I like to open up in prayer, so that's the first thing I'll do each time we meet. So let me just go ahead and open up in prayer, and I'll give you a rough sense of what we're going to be covering in the course and what we'll be covering today. And so, dear Heavenly Father, Lord, thank you for the chance to be working with each of the students in this course, Lord. I pray that you would begin a work in them that will lead to a bright future. And I pray that courses like this and the degree work that they're doing here that will help them to get the job in the future that they would like. We just invite you here in our midst. In Jesus' name we pray. Amen. So it's really wonderful to have a full classroom. So I just wanted to once again say thank you. And how many people, what did you guys think of when someone says the word engineering? Anybody have an impression that starts to come to mind when someone says that? Go ahead. Problem solver. I like that. Go ahead. Robotics. Yeah. It's I've been talking with couple of other engineers and looking at other programs around the country that I have friends that work there, and structures, robotics. There's just a lot of that's all over the place. Mechanical engineering is a huge component of the engineering set of things that happen, and all of that is, as already mentioned, of being a good problem solver. So I'm hoping that this course is a wonderful introduction for you to something that I think is pretty fascinating. I can remember when I first started my studies as an engineering and did my internship, a person I knew at church, I got introduced to them, and it led to a time when I had an internship between my junior and senior year. That's something that you guys can be looking forward to. There's a lot of things to get a chance to get familiar with. And I really like the textbook that we have here, and it's showing up here on the cover. So I've used this for a handful of different courses that I've been have had the privilege to talk about engineering. And so the title of the course is Introduction to Engineering and Computing. And we're going to get a chance to talk about both of those. And so the way I'm treating the information and that we have in our textbook is a survey fashion. So we're going to try and cover everything because it's actually really well comprehensive in what we're trying to do. And so this is, if you look in the catalog at APU, what it states for Introduction to Engineering and Computing. Students in the course will get an overview of engineering computing as creative and responsive professionals, or problem solver. So maybe we should put that in here as well. And learn about the qualifications of engineering and computer scientists and the way in which they study, think, work, create, design, and communicate. All of those are very important, and you put that together, that just gives you a very marketable set of skills. So the course material will also cover the impact of engineering computer solutions in global economic and societal contexts, case studies of effective civil government and social engagement in engineering and computing ethics. So we're going to get a chance to get a perspective on all of those things. And here is what is the contents for our textbook. And so I like the way they start here. Engineering an exciting profession. I think it is quite exciting. Some of you may be going into computer science versus engineering. They're both, I would say, have some overlap, and we're glad that we get a chance to teach both of those topics here at APU. So what I'm going to talk about today is I'm going to be focusing on an introduction to the engineering profession as we do this 5-chapter introduction to what it is. And then we're going to get into more specifics. Guess what? You have to know physics, you have to know math. And so I think probably that's not a surprise to you folks, but maybe as a result of going through it from an engineering perspective, it might give you a perspective that there's something at the end of the rainbow that's worth going through all of that, and we'll get a chance to be seeing that from a couple different points of view. We'll talk about the computational tools that engineers use. And believe it or not, spreadsheets are something that's quite amazing what you can do. More specifically, Excel, but I think Google Sheets also, you can do some of those things. Coding, you can actually turn a spreadsheet into an application. I've seen that done in various projects and various groups that I've worked at. We'll talk about MATLAB. Everybody, have you heard that MATLAB? MathWorks, it's a real powerful set of capabilities, and MathWorks has, and MATLAB is the anchor tenant for all that. But it's not the only thing. You can also do some pretty amazing things with programs like Python and all the libraries that extends it. And so we'll get a chance to be thinking about that. Then there's some of the other more specialized things about graphical ways of communicating information, whether it's CAD drawings and different types of symbols that are used in that area. We'll be talking about design decisions. And so problem solver, we've heard that already. There is a fair amount of what's in the engineering mindset of how to accomplish that. And finally, we'll finish out with some of the other things, mathematics, statistics, and economics, the mathematics of engineering, return on investment, how is it you can do it, but is it cost effective to do it? What about the probability and statistics that are associated with engineering? And finally, the engineering economics. So chapter 2, we're not going to get into it today, but there's going to be a whole chapter on preparing on an engineering career, including what courses are you going to take? What is it that you want to be doing in your future? All of those are things that are quite important to be beginning to get your thoughts around as we progress. So I'm going to go into chapter 1, but before I do, I want to walk through some of the resources that are in Canvas so that you can see that. And every time I do that, unfortunately, it stops sharing my screen. So let me share my screen again. And so are you guys familiar with the term learning management system or Canvas? You guys ever used that before? So it is pretty, as an instructor, and also I've used it as a student, it is quite effective in a way of mediating a lot of information. And so I try and mediate everything through Canvas. And so it's a one-stop shop. You can also get it on your tablet, on your phone. I use it all the time on a tablet. So that's another way that you can be engaging, walking through some of the assignments, be aware of some of the things that we're going to be utilizing. So on Tuesdays, we will be meeting face-to-face. And on Thursday, we're going to be meeting via Zoom. And the reason why I do that is I try and have things that are more project-based that we'll be doing on Thursday. I can spend some more time walking through MATLAB and Python and some of these other things that might be of help. And also getting some feedback as I start to get some perspectives on what areas of engineering and computing that you're focused on that can help me to spearhead maybe some things that would be more topical and useful for you. So what I'd recommend that you do is while we're in class, just click on this Zoom link and make sure that it works. What I should see when you do that is that you'll pop up here on the participants. And that is one of the ways that we can verify that you guys are successful in logging in. You can log in on your cell phone, your tablet, your computer, just about anything. And so it's real easy to do that. And so Benjamin, glad to see that that worked for you. And so each one of you can feel free to try that at your leisure. So there are going to be a couple things that we'll be having. Since I really like the way that our textbook is organized, we're going to mediate a lot of the material based on that. There'll be some quizzes, one quiz per chapter. And so we have that. And so these aren't very long. There's just multiple choice, true or false, those types of things, just to give you a way of engaging a little bit more with the material in each of the chapters. You can take these more than once if you like. And so these are just meant to be a way of helping you to get familiar with the material. And also another way that I did is I have a review. And so you can just write a little bit of a synopsis of the chapter of what are some of the key points that you got. And so that is just another thing that we'll be using as a way of just helping you get familiar with this in general. I really like this idea of having project components to courses because that actually gives you a chance that you're going to be acting more like what it's going to be like in the future when you're employed. And so you propose an idea, you get it funded, you do a midterm review, and you do a final report. These are the kind of things that I do all the time in my professional life that I've done. I've worked at several aerospace corporations, research and development companies. And so these are the kind of things that you would end up doing. So what would be something that you would like to focus on? And so here it just gives you some of the ideas of what it would like. Having, well, first of all, what are some ideas? I put some in here that you can be thinking about creating a phone of your own design. You can pretend like you're Apple and they're coming up with a new phone if you want. Design or evaluate some simple structure. So some of you might have more of a mechanical point of view. And I'm not saying it has to be one of these. I'm just trying to have you begin to think of some ideas, the kind of things that engineers do, and you could start to flesh it out. A solar mobile phone charger. So say you're in a third world environment and you just can't go to the local outlet and charge your phone. So what about creating a solar charger? You could have an automobile automatic solar tracker. So it has it's going to have some kind of sensor that's going to be tracking as the sun moves across the sky. Satellites do that, for example, as they're trying to get the most illumination and the most power generation. A wireless lock system. A course that I teach for juniors, it uses Arduinos, and that will be something that maybe if it's a term you haven't heard before, but it's a little device, a cyber physical device where you can connect hardware and do some simple programming to try and figure something out. And so this would be an example of something that would be something that could be done leveraging some wireless communication technologies. Well, let me just pause for a second and just do a round the room. And maybe this would be related to why did you choose engineering? What do you think would be something that is especially interesting to you? I heard something about robotics a little bit, what folks were mentioning about what they think engineering is all about or what interests them. Any thoughts that people want to share on that? Go ahead. Oh, robotics. So this would be something that would be interesting for you. And so for this type of a project, this is an introduction to engineering. So you can just begin to, what are some resources on robotics that you're finding online or something like that? Or what would be something that you would like to demonstrate? Maybe you don't actually demonstrate it in this course, but you create a plan. And so you have the proposal, you have a midterm, you have a final. You could try some of that, or you could actually maybe try and begin to utilize some of the resources that you might want to to do along that line. Bless you. For example, bless you, you can get MATLAB. There is a MATLAB Basic that everybody can get. It's free. And so this is a link for that. You can get a MATLAB version it's fairly affordable. I'm just trying to give you some ideas. I'm not trying to say this is what you're going to do, but just have you think about it. So this is going to be due in fairly soon, just to have an idea. And why I wanted it sooner than later is because I want to be engaged with each of you to, first of all, conceive of an idea, and let's start to mature that as we go through our course. Okay. So Thursday is going to be a time that we can get into, once I get a better sense of the things that you were interested in, I could tailor some of our time around that and see if we can make it fun, but also relevant for the things that you find are most interesting. Okay, I'm going to go back to the lecture notes and spend a little time focusing on some of the material from chapter 1. And I have a couple of embedded videos that will also be enjoyable for us to think about that. Here's some of the things that they're saying. So chapter 1 is an introduction to the engineering profession. So what does it mean to be an engineer? Say 5 years from now, reporting to work, what is your life going to be like? What are the kind of things that you're going to have to do? We've already heard problem solver. So you could write this down. You can just think about it in your mind. Write a few sentence response to the following prompt. Name 3 skills that an engineer should possess. And discuss what you know about the engineering profession. So let's just think about that. If you want to take a few minutes, or if you have something already off the top of your head, please feel free to just vocalize that, and let's begin to have a conversation. What kind of skills do they need? We already have one, problem solver. Patience. Go ahead.
You have to be creative.
Creative. That's something that sometimes people don't realize, but engineering and computer science is very creative. I think you saw your hand up. Teamwork. That's really, really important. And so I'm glad that you mentioned it. So a variety of hands back here. So communication skills. It's okay to say the same thing again, because that just means that we're all thinking on the same line. That's good. Go ahead. Being realistic.
I mean, like, at the same time, I guess just understanding that I guess some things may not be like achievable in a certain way. You know what I'm trying to say?
Yeah. Being realistic. And go ahead.
Having persistence.
Persistence. Amen. That is really important. All of these are important. Go ahead. Open-minded. Yeah. So all of these are really good. And you're going to see now, this is going to be in the terms of the author of our textbook, but I would agree with him that what he's postulating of what are these characteristics that an engineer or somebody in computing would have. And for each of these chapters, I don't need to go over these in detail, but there's the chapter objectives. And so by the end of this chapter, you should be able to, engineering work is all around you. Give examples of products and services that engineers design that make our lives better. I mean, I'm using a laptop. Guess what? Engineers were involved with that, as well as computer scientists to make that happen, making it light, that it could actually go on battery for a long enough period of time, that the screen is bright enough, that the keys are just the right sensitivity. It just goes on and on. Basic human needs, the challenge world population, age structure, and sustainability. Explain the basic human needs, the changes in the world population, age structure, and what is meant by sustainability. How can we help those that are less privileged than us to have the resources to improve their quality of life? That can be an example of something as engineers we can help out with. Engineering as a profession, you can describe what engineers do and give examples of common careers for engineers. My particular, just by the Lord's providence and what was provided for me, aerospace is the thing that I went into. I'm not saying that's what you guys are all going to do, or maybe not even most of you would be interested in, but the Lord is going to provide various things that are things you're interested in, and just watching how it unfolds, that the opportunities come your way. We talked about the common traits of good engineers. We'll get into that more and describe the important traits of successful folks acting in that profession. And then engineering disciplines, so give examples of common engineering disciplines and how they contribute to the comfort and betterment of our everyday lives. And so engineers and those that are in computing, they really form a very vital backbone of so many things that we have in our life. Just think into this building. For those in civil engineers and mechanical engineers, they had to design for the structures, knowing what the weather, climate patterns are. Maybe some of you have lived in different parts of the country or around the world, and say you're in a place where there's a lot of snow, then you have to design differently for some of the things. You have to have more temperature dynamics that have to be part of a housing design. And that's just one example of something that would be out there. So here we see a cell phone, and we can see how it's not just only something that makes phone calls. It's showing some things related to IoT, that you can control various things through the interface of a phone. That's where things have been going a lot. So there's things like computers, microwaves, smartphones, and washing machines. There's also things contributing to the comfort and betterment of our everyday life. Maybe you've seen some of these devices where if it's a getting or other ways that it's getting more and more finesse in how we can be creating ways to make getting around easier. E-bikes is probably the thing that's just taken over quite a lot in a form of transportation, where engineers have definitely been part of that. Well, here's one of first of two videos I'm going to show. And so let me see if this is okay. It's in full screen mode. I'll just go and play this, and hopefully this sounds about the right level.
They'll come up with all kinds of ideas, and some that might even seem a little crazy. Because sometimes the craziest idea is the one that works best. After coming up with these ideas, they'll pick a few that make the most sense. Next, they'll start drawing a plan. Depending on the idea, the plan can be very simple or very complicated. But the important part is the plan itself. A good plan helps engineers focus on what they're making, and most importantly, why. Now the engineers get to have some real fun. They get to create something. It's important to stick to the plan, though, so the idea doesn't go too far off course. Once they've built it, then they have to test it. Experimentation is very important, because it's here that engineers learn what works and, well, what doesn't. And while it's great when something goes right on the first try, it's actually good when things don't, because that gives engineers a chance to go back and improve on their original idea. And improve they will until they've solved the problem. So the next time you've got a problem to solve, whether simple or complicated, there's probably a team of engineers ready to create something to solve it. And nobody solves engineering problems quite like NASA.
I'll be using some NASA examples, partly because they're readily accessible. Once again, it's just an example of one of many possibilities of what you could be doing. But it is a fairly open set of things that they provide some information about what it's like to be an engineer, so you can be thinking about that. So what type of engineer would design the components of a refrigerator? Anybody have an idea what you think that would be? Go ahead. Electrical, okay. Mechanical? You know, I'm an electrical engineer, so I'm a little bit biased, but you know. But just to put it here, this is what they were saying, and from their point of view, and really, it's like I could argue for, especially for the Internet of Things, where things are moving, that electrical engineers are going to be having a part into it. But what they're talking about is the nuts and bolts of doing that temperature heat exchange, and so that's what they're focusing on. So mechanical engineers would design the refrigerator components, and chemical engineers would investigate alternative refrigerant fluids with appropriate thermal and other environmentally friendly properties that can be used in the refrigerator. Maybe some of you have heard of something called Freon. And so for air conditioning units of cars, that used to be quite common. They've tried to move away from it because it wasn't good for the environment. So that's an example of an engineering trade where they came up with a better approach to how to do things that has that function, but something that's more environmentally friendly. So basic human needs, the changing world population, age structure, and sustainability. How can we make think in terms of not just doing things, but doing things in a sustainable manner? And so that's just something that's out there. So how can we do things that also promote having clean air, for example? What does that mean in terms of power plants, factories, or anything else that comes into things that could pollute the air? Cars, buses, trucks, planes, and trains, as well as the natural type of air pollution that exists, that maybe we can try and minimize forest fires, if at all possible, the way that we might at least be caring for forests that are in the neighborhood. I've heard that they do this in Europe, that they actually prune their forest. Here, especially in California, we don't tend to do that. But in Europe, it's a lot more populated. So a forest might be acres or maybe hundreds of acres, but then there's a city right next to it. And so some of the debris that's among trees, they may use that or just remove it, so it's not causing all of this fuel to be available that could cause a huge fire. Maybe there's something there that we should be thinking about what we would do here in the United States. What about dealing with climate, things that might be there, and what can we do to be good stewards of God's resources? There's stuff like that could be there. They talk about global environmental changes. Some people may not see that as that the way that it actually is, but putting that aside, that it still is something that we can be thinking about, how to be good stewards of the earth, and what are some things that may actually be happening. So the carbon dioxide emissions have increased over time. And so this just gives a range of going close to 40 years. Though, so, well, maybe that's not a good sign. Maybe we should be thinking about how we could be leveling that off. What about clean water? Agriculture, all of the things that we do to increase production for fruit and vegetables, fertilizers, pesticides, etc. Are we actually doing things in the best manner that is helping the environment? This is something the formal word is called meteorology, and so this is looking at the weather and water, and so things are just recycled all the time. And so what comes around goes around. And so this, just without getting into some of the details of the specifics of the water cycle, we want to be thinking about how we deal with stuff like that. In terms of food, we would like to have everybody to have a high nutritious food wherever they're at. And so we want to be maintaining a healthy body weight, and we want to be making sure that everybody has the proper amount of calories and nutrition. So these are just some examples of the things that are out there. This may be a little bit hard to read, but this shows the food dollar and on the top, and let me see if I can get that out of the way. So on top, it's the food dollars marketing bill. And so farmers make about 14.3 percent out of the total food dollar, while marketing is 85%. So that just gives you a perspective from that point of view. And the various industrial groups that come into thinking what goes out into to food production. So it's just something to be thinking about these different areas. We need natural resources to make goods to make goods and provide services. We need energy to do these things. And so here are examples of the type of energy that's produced. The largest amount is petroleum-based energy production. Renewable energies is starting to go up. My wife and I just a couple years ago got solar panels and batteries for our home, so that helps. The population age structure is also changing. There's a growing number of seniors in our population mix, and so that actually changed how things are going. And these are yet another example of an engineering type of challenge that needs to be addressed. So engineers are expected to design and provide goods and services that increase the standard of living and advance healthcare, while also considering the links between Earth's finite resources and related environmental, social, ethical, technical, and economic factors. So a lot of things for us to be thinking about. So it's interesting, I was reading a documentary on the Industrial Revolution, and I didn't put this together, but the first Industrial Revolution actually happened in Great Britain. The railroads were first laid out, and they could actually have this more effective movement of goods and services, and how things could really start to prosper in a way that wasn't actually known before then. The second is the Industrial Revolution, the things that we would probably think of the revolution that we're familiar with here in the States, how things were made, factories and mega factories were created. So the third industrial revolution is that of computers. Now it's quite commonplace, but once upon a time there wasn't such a thing as email or the internet. And finally, the fourth industrial revolution, these innovations have led to better decision-making and a more efficient way of doing things. So the information industrial revolution, thinking what we can do with a lot of analytics and making better informed decisions. Any questions on what I covered there? Any thoughts? So it's one of the, this textbook gives the dimensions of a lot of different areas in engineering. And so sustainability is one of those. And this is something that we can be thinking about. The United Nations even has an area for sustainable development. It's one of the things that they consider. So here's a question just to get some of your perspective. The what accounts for energy use in homes and apartments? Residential? Right. The residential sector accounts for energy use in home and apartments. Think about the space, heating and cooling equipment, lighting systems, electronic devices, and applications such as refrigerators, freezers, ovens, washers, and dryers. They are used in our homes every day. So that's stuff that we know about. So what about engineering as a profession? So what do you guys think of 5-10 years from now? What do you think you would like to be doing? Anybody? What was the motivation for you to start studying engineering here at APU? Anybody want to share? Go ahead.
Software engineer.
Software engineer, cool.
I don't know what's happening. I just don't.
Good. So you just like the Jules Verne, if you've ever heard of who that is, but just thinking about just the mindset of an engineer and doing things that are in that area. Go ahead. CAD and robotics. Yeah, that's amazing. There's a lot of things that are going on there. Go ahead. Aerospace, yeah. So the videos that I'm showing, a lot of them are going to be aerospace related, thinking in terms of NASA, but that's one segment of what's going on in aerospace. This area, there is a lot of aerospace industry that's a part of what's going on. So keep that in mind of what motivates you. What is engineering and what do engineering do? So they consider important factors such as cost, efficiency, reliability, sustainability, and safety. They perform tests to make certain that the products they design withstand various loads and conditions. They continuously search for ways to improve already existing products. And that short video I showed earlier got into that a little bit. They design and supervise the construction of buildings, dams, highways, mass transit systems, power plants, etc. They play a significant role in the design and maintenance of the nation's infrastructure, including communication systems, public utilities, and transportation. So I don't know if you've ever been through a power outage. It's not fun. So that's an example of what an engineer is trying to do, is maintain that. They continually develop new advanced materials to make products lighter and stronger for different applications. They're responsible for finding sustainable ways to extract petroleum, natural gas, and raw material from the earth. And finally, they innovate the ways of increasing crop, fruit, vegetable yields, along with improving the safety of our food products. It's not my area of expertise, but I've heard that some ways of producing crops, there is some innovation, at least in third world areas, where they've been able to renovate what was like desert areas. And just by having the right mixture of plants, they're able to revegetate those areas, and it starts to get the ecosystem where they can have more growth, and thus there could be more fruit and vegetables that could be part of what's there. Okay, well, let's think about this engineering as a profession. And this video that I'm going to show next was an individual a few years older than you. So just imagine someone's like 5 years older than you who became an engineer working for NASA. And let's get a chance to hear a little bit about her story. Well, it worked before, but it doesn't seem to be working now. So sorry about that. Maybe if I get that working some other time, I'll play it later. But anyway, it was someone like you who got interested in engineering. And as things just worked out, she got her degree. I think she did an internship at NASA. And then after she finished her schooling, she really liked the NASA environment and decided to keep working there. So that would be for folks that live here. I don't know if you live here or you're coming to school for here in Southern California, but working for JPL would be the example of one thing that could follow along that line. Okay, well, what are some of the common traits of good engineers? Problem solvers. So we've heard that already. Good engineers have a firm grasp of the fundamental principles of engineering. They're analytical, detailed-oriented, and creative, all of that in the same line. They have a desire to be lifelong learners. They have written and oral communication skills. They have time management skills, and they have good people skills. So technical skills and these soft skills are all important. All of those are things that contribute together. So what do you think this? engineers generally work in a what environment? Anybody have an idea? Team. So they definitely work in a team environment where they consult each other to solve complex problems. They divide up the task into smaller manageable problems among themselves, and consequently, productive engineers must be good team players. So I haven't set up this course that we're going to be doing things in teams, but there will be some of the courses you'll be taking here at APU that you'll get a chance to be exercising in and see what that's like. So we mentioned this a little bit about engineering disciplines, the type of engineering specializations that they are, and some of you are still trying to decide what that might be, and that's perfectly fine, but let's expose you to some of those things. And so here, there are over 20 major disciplines or specializations that are recognized by professional engineering societies: civil engineering, constructing buildings and roads, electrical and electronic engineering. I'm an electrical engineer. Mechanical, that's the most popular in terms of the numbers that's out there. Petroleum engineering, those are just a handful of ones that are out there. The Accreditation Society for Engineering. So APU is now accredited, its engineering program is accredited with ABET, which is the Accreditation Board for Engineering and Technology. So it examines the credentials of the engineering program's faculty, curricula, content, facilities, and admission standards before granting accreditation, and ensures that engineering programs offered by an institution meet defined standards of quality. It may be wise for you to find out the accreditation status of the engineering program you're planning to attend. And we're accredited, so that's the good news. We just got that. So I mentioned this already for civil, electrical, and mechanical, aerospace, since that was also one that came up. Aerospace engineers design and develop, test, and supervise the manufacturing of commercial and military aircraft, helicopters, spacecraft, and missiles. So it's aero, planes, and space, making one word. So mechanical engineering, the major branch of the mechanical engineering include thermal and fluid systems and structure and solid systems. Electrical, the major branches of electrical engineering include power generation, power transmission, distribution, and controls. There's also something called system engineering. And has anyone ever heard of system engineering? We actually teach a class in system engineering in the spring. And so that may be something that you would like to take one time or another. And then I mentioned civil engineers as they define buildings, roads, highways, bridges, dams, tunnels, mass transit systems, airports, things like that. Biomedical engineer, Dr. Chen has this as an area of specialty, but she also has a lot of general, very competent general engineering skills. Biomedical engineer is a new discipline that combines biology, chemistry, medicine, and engineering to solve a wide range of medical and health-related problems. Chemical engineering, chemical engineers use the principles of chemistry and basic engineering science to solve a variety of problems related to the production of chemicals for various industries. Environmental engineers, they apply the laws and the principles of chemistry, biology, and engineering to address issues related to water and air pollution. We were talking a little bit about that earlier, and so you can see this is be an area where environmental engineers would play out. Manufacturing engineers, dealing with manufacturing, petroleum, thinking of how to produce petroleum in effective ways, nuclear engineering, nuclear power plants that are safe, mining engineers, mining various resources out of the earth economically and safely. Materials engineers work in developing and testing new materials for various products and engineering applications. There's tons of that. So in engineering technology, the scope of an engineering technologist's work is more application oriented. It requires less understanding of mathematics, etc., engineering theories and scientific concepts than are used in complex design. Although as a lesser degree than engineering, engineering technologists use the same principles of science, engineering, and mathematics. So we're all thinking about engineering, but you may end up be working with folks that are engineering technologists that maybe, at least where there are at the time when you spoke with them, haven't produced, gone in degree work that has led them to that next step. Okay, well, let's do a knowledge check. So something engineers design, develop, test, and supervise the manufacturing of commercial and military aircraft. Aerospace, good job. So these are all things for you to be thinking about, like, well, okay, you have an idea of what you're like to work on. Maybe what you do with your project proposal and your plan and work in the semester, you can start to play that out. You might end up finding that a different type of engineering may be what you would want to do instead, or it'll just enhance the desire to what you want to be working on that one area. So I think that's about what we have here. We listed the objectives at the beginning. And so as a result of going through that material, you have a little bit better sense of what we're trying to do with this first chapter as we get an introduction to engineering. Let me see if there's any comments or questions about what we just covered, or any comments or questions about the course. Anybody have an idea what you'd like to do your project work on? And maybe we could just spend just a few minutes just brainstorming about that. Anything that you're really excited about? Go ahead.
Making ocean water drinkable.
Mm-hmm.
Yes, I saw this, where you was able to, I guess, produce water by using this, like, I'm not sure what he does, I think he with the company or whatever, but basically he just creates water.
Mm-hmm.
Try to understand maybe everything.
Yeah, that's a great idea. And that also gives a way of basing what I mean by the project. You know, it's a short course. You're just starting your journey in getting an understanding of what engineering is, doing a little research, like what you mentioned, creating water from air. I know there's a scene or two. I don't know if anybody likes sci-fi, maybe the guys more than the gals here, but Dune, did you see the second part of Dune? Where it shows like that little mouse and then that one tent that it actually takes the moisture out of the air and puts it back down so you can actually make it drinkable. And that seems to be online to a degree of what you're thinking about. But now instead of it just being a sci-fi movie, it's actually real. And so fleshing that out, water purification in one form or another. So that's an example. And as we go through the course, you're going to see what it means to think like an engineer. How do you take general ideas and put them into requirements, into something you can actually do? What is it that you're going to actually do? Taking a general idea and put it into a specific language. A requirement is a sentence that has a shall. The something shall, and then what is it supposed to do? And it's like to what level or something like that. So that's a good idea. Any other ideas of things that come to mind that sound interesting to you that you'd like to do some research and have for your project? This isn't casting it in concrete, it's just having us think, so. We'll just keep thinking about that, okay? And Thursday, we'll continue our conversation and we'll just continue to be covering more stuff in our textbook. And as I get to know you guys a little bit better in your areas of interest, I can introduce some different things in one area or another that might be something that would be beneficial for you to see some of these things in action, okay? So I think that's probably a good breaking point for now. I'm really looking forward to sharing this class with you all. And once again, welcome to APU. So I'll stick around for a while if anyone has any comments or questions, okay? Take care.
Oh, we haven't even-
Excuse me? It'll be via Zoom, so wherever you feel comfortable that you'd like to join, that'd be great, okay?